Hello dear friends, I'm Erisa once again to teach you mathematics online. Yesterday we introduced matrices for ordinary level students, and in our discussion we defined what a matrix was, the order of a matrix, and we went ahead to talk about addition and the subtraction of matrices. Today we want to continue with the addition and the subtraction of matrices so that we can get into the depth of this. It's not something really hard, but we have to emphasize this point so that everybody understands what we're talking about. We say that for two matrices to be added or subtracted, the two matrices must have the same order. And what we do in adding or subtracting matrices, we add or subtract the corresponding entries. That's what we introduced in our first lesson yesterday, as we introduced the mathematics. Remember, this lesson is intended for ordinary level students. The content is not so much for an advanced level students, so I've done this for the little ones so they can also get something in mathematics. So we have been given four matrices, P, Q, R, and S. They are telling us to find where possible. Let's write this on the next page. So we have been given the matrices and they want us to find P minus Q, Q minus P, R minus S, and R minus S plus Q. Okay, so they are saying find where possible. So if it's not possible for you to compute, whatever they are asking you, don't do it. Remember, we only subtract or add matrices if they have the same order. So that's why he's bringing in the other thing, find where possible. So if not possible, will be determined by the order of the matrices. Let's look at this. So if you compute P minus Q, this will be 14, 2, 6, 7, minus 5, 15, 8, 3. And we said we subtract the corresponding entries. So this is going to be 14 minus 5. Okay. Then we have 2 minus 15. Then we have 6 minus 8. Then 7 minus 3. Okay. So P minus Q will be equal to 14 minus 5 is 9. And the 2 minus 15 is negative 13. Okay. 6 minus 8 is negative 2. And then 7 minus 3 is a 4. So as simple as that, you have P minus Q. Okay. What about the Q minus P? Okay. Just the reverse of this. Now I want you to work out this. I'm sure this is going to be negative 9, 13, 2, and negative 4. That's now your task, because it is almost the same as this, but you just interchange which matrix comes first and which one, that is it. So let's look at R minus S. R minus S. This is possible because these two matrices have the same order. Okay, is 3. So this will be So we'll have 3, 4, 8, 2, 1, 0, 6, 8, 12. And then I'm subtracting 12, 4, 7, 5, 16, negative 1, 8, 3, and 4. Okay, what do we have? 3 minus 12, 4 minus 4, 8 minus 7, 2 minus 5, 1 minus 16, 0 minus negative 1, 6 minus 8, 8 minus 3, and then 12 minus 4. Okay, you have to show this step that you're subtracting. Don't just compute and write answers. They're not good. You end up losing some marks just for explanation purposes. You have to show the step. So 3 minus 12 is negative 9. Okay, 0. 8 minus 7 is a positive 1. This is 1. Okay, negative 3, negative 15 minus, that's okay, negative 15. Then a positive 1 minus 2, a 5, and the 8. That is R minus S. Okay, as simple as that, you have subtracted the two matrices. Addition is done the same way, just add the corresponding entries. We did that in lesson 2. In lesson 1, towards the end of lesson 1, we were able to add some few matrices, and this is just a follow-up. We're trying to build on what we talked about last time. So this is not something which is so strange. Anybody can answer this. It's not really a problem. Okay, next they are telling us to compute. We have P minus Q, okay, R up Q minus P, okay, L minus S, then S minus P, okay, S minus P. When you look at matrix P, I think I'll do this on the next page, but let me try it right here, okay. P equals to 14, 2, 6, and 7. And this is a 2 by 2. Then we have S is equal to 12. We have it above, okay? Let me not just waste because I have limited space. So S is a 3 by 3. Much as P and S are square matrices, subtraction in this case not possible because they have different order. One is a 2 by 2 and the other one is a 3 by 3. So you can't subtract a 2 by 2 matrix from a 3 by 3 matrix. It's impossible. Okay, remember we subtract corresponding entries. Therefore P S minus P is impossible. Okay, because of the order of the two matrices being the same. I have summarized for you some of the properties of matrix addition. If we want to add two matrices A and B, then adding A to B will be the same thing as adding B to A. And that's what we say, that matrices are commutative, okay? The meaning of this is just simple. It's like adding real numbers. When you have 2 plus 3, the same thing as 3 plus 2. You get the same answer. So matrix addition is commutative. And if we have three matrices A, B, and C, and we want to add A to the sum of B and C, it will be exactly the same as getting the sum of A and B and adding it to C. So in that case, we see that the matrix addition is associative. Okay, then there is a unique M by N matrix 0 with A plus 0 is equal to A, and that is the additive identity. So what do we mean by this? If I have a matrix 1, 2, 5, 3, and I'm adding on that matrix 0, 0 matrix will be of the same order but with all entries 0. Okay, so this will be 1 plus 0, 2 plus 0, 5 plus 0, 3 plus 0. And then you exactly end up with the matrix A, a matrix which is 1, 2, 5, 3. So the 0 matrix with what we call an additive identity. Okay, then we also have what we call additive inverse. If we have this matrix 1, 2, 5, 3, okay, the negative of this matrix is what we are calling B. So plus, minus 1, minus 2, minus 5, minus 3, okay, is the same thing as 1 minus 1, 2 minus 2, 5 minus 5, 3 minus 3. And it will give you a 0 matrix, which is 0, 0, 0, 0. Okay, so these are some of the properties of matrix addition. You know, They're not so important, but I wanted just to give you some of this information. It will be useful to you. They're important as we go on, with the matrices at higher levels. But at your level, things are going to be too practical. But it's also good for you to understand what we are talking about here. Let's talk about multiplication of matrices. The first multiplication we're going to talk about is scalar multiplication. Scalar multiplication means that you are going to multiply a matrix by a real number. A scalar is a real number which can be a positive or a negative number, or it could be a fraction, okay? All integers and the fractions are real numbers, okay? So if you have a matrix A, which let's say it is A, B, C, D, E, F. So we have that matrix, okay? And the K is a scalar, okay? Then K times A will be equal to K times A, B, C, D, E, F. And each of these elements will multiply by K, okay? So we have KA, KB, KC, we have KD, KE, and then KF. So that's what we mean by scalar multiplication, multiplying a matrix by a real number, okay? Now, if A equals to 3, 2, 5, 6, 1, 7, okay? Then, okay, 4A will be equal to 4 into 3, 2, 5, 6, 1, 7. Okay, that means we multiply each of the elements of A by 4. Okay, this will be 4 times 3, which is a 12. 4 times 2 is 8. 4 times 5 is 10. 4 times 6 is 12. 4 times 1 is 4. And 4 times 7 is 28. So 4A gives us 12, 8, 10, 12, 4, and 28. Okay. So we have learned how to multiply a matrix by a scalar. Okay. Now, what about the reverse? What if they give us a matrix and we want to factor out something? So we can write here that, okay, it also means that in reverse, okay, we can take a common factor out of every element. Okay, so we can take a common factor out of every element. Therefore, if I have a matrix which is 10, 25, 45, 35, 15, and 50, okay, this can be written as, we can write this as, you'll discover that 5 is a common factor here. Every element can be divided by 5. So 5 divides 10 2 times. 5 divides 25 5 times. 5 divides 45 9 times. 5 divides 35 7 times. 15 3, and here it is 10. So we can take a common factor out of a matrix if it is common in each and every entry. Okay, so that is also a scalar multiplication, because we are now bringing it out. Okay, so that is something I wanted to teach you about, and we can use this knowledge to answer this question. Let's see, they are giving us, so this is a simple question. They are giving us two matrices A and B, and the question is demanding us to find 5A plus 4B. Okay, what do? We multiply 5 by matrix A and add it to 4 times matrix B. So we end up with 5 into 1, 3, 5, 2, 4, 6, plus 4 into 3, 2, 1, 1, 0, 1. Okay, so what do we get? Multiply 5 by each element of matrix A and multiply 4 by each element of matrix B, and we add together. Let's see what's happening here on the next page. Dear friends, 5A plus 4B will now give us, okay, 5 times A, this is a 5, 15, 25. This is 10, okay, 20, and 30. We are adding to 4B, and 4B, 4 by 3 is 12, okay, 8, and 4. Then 4, 0, 4. Now we add the corresponding entries because each of these matrices is a 2 by 3. So this can be 5 plus 12, okay, 15 plus 8, 25 plus a 4, 10 plus 4, 20 plus 0, and then 30 plus a 4. Okay, so in the end, what do you get? 5 plus 12 is 17. 15 plus 8 is 23. Okay, and 25 plus 4 is 29. So this is 14, 20, and 34. So we have used the scalar multiplication to add 5A to 4B, and we have the answer. Okay, so next is just something very simple. Okay, now let me give you example 2. Example 2. In example 2, they are saying that given that matrix P equals to 4 minus 6, 0, 10, and matrix Q equals to 3, 9, negative 3, and 0. Okay, so they want us to find, what are we finding? 2P, just as simple as that. Okay, then also find a third of matrix Q. Okay, then we find a half of P minus a third of Q. So just as simple as that. Dear friends, let's go through this. It's just some simple work, you know. This is not a problem to you as an ordinary level student. I'm telling you, this is just going to be very interesting. So P has been given to us as 4 minus 6, 0, and 10. Okay, and the question wants you, okay, let me write both. Then Q was also given to us as 3, 9, negative 3, and 0. Now, the first part of the exercise, they want you to find the 2P, okay? Just get it 2 and multiply by matrix P, which is 4 minus 6, 0, and 10, okay? This 2 by 4 is 8, okay? Minus 12, 0, and then 20, that is 2P. Then the next one is a third of matrix Q, okay? just multiply each of the entries of Q by a third. 3, 9, minus 3, 0. Okay, this is 3 over 3, 9 over 3, negative 3 over 3, and 0 over 3. But knowing that 0 divided by anything, you get 0. This is 1, 3, negative 1, 0. Okay, we have that solved. Then the third is, they want to look at a half of P minus a third of Q, which is a half of matrix P, 4, minus 6, 0, 10, okay, minus a third of Q. We already have it as 1, 3, negative 1, 0, okay. So what do we get here? This is 4 by 2 is a 2. Negative 6 by 2 is a negative 3. Okay, this is 0. This is a 5. Then take away 1, 3, negative 1, 0. And we said we subtract the corresponding entries. So this is going to be 2 minus 1. Okay, negative 3 minus 3. 0 minus negative 1, and then 5 minus 0. So we end up with 1, negative 6, 1, and 5. Okay, so it is as simple as that. Why don't I give you this and you try it out as you are busy having a cup of tea? So after scalar multiplication, under multiplication of matrices, 2, we talk about the multiplication of two matrices. When do we multiply two matrices? Okay, let's put down some literature. So under multiplication of two matrices, the point of emphasis is 1, okay? Two matrices can be multiplied together only when the number of columns in the first is equal to the number of rows in the second, okay? Look at the number of columns in the first matrix and compare with number of rows in the second matrix. If the two are equal, then you're gonna multiply those two matrices. And this is what we call the compatibility test of matrix multiplication. Okay, remember the order of a matrix. We write a row and then a column. Okay, so what's the point of emphasis? Okay, the point of emphasis is about number of columns. Number of columns in the first must be equal to the number of rows in the second. Okay, that is so important. Now there's something very interesting here. If A is a matrix of order m by n, that's the order of A, and the B is a matrix of order n by r, okay, then the product AB is possible. Why are we saying the product AB is possible? It is this factor. You know, in A, these are rows here. These are rows and these are columns. Okay, and in matrix B, okay, these are rows and then columns. And we say that for you to be able to multiply two matrices, then the number of columns in the first matrix must be exactly equal to the number of rows in the second. So when you look at this, this is n and this is n. Therefore, it is possible for us to multiply these two matrices. And then the order of the matrix we're going to get will be m by r. Okay, so let's look at an example and see how we multiply two matrices. And remember, when you're multiplying matrices, okay, you multiply row by column. Let's look at this question. Given that the matrix A is 1, 2, 3, 4, 6, 5, and B is 7, 8, they want you to find the AB, okay? So how do we find the AB? Is it compatible to multiply A by B? That's what we have to look at. So in our solution, okay, we say that A has order. Look at A. we have how many rows? 1, 2, 3. So those are 3 rows. And how many columns? 1 and 2. Those are 2 columns. Okay. And the B, okay, has order. Let's go to B. This is the first row, the second row, and only 1 column. So it is a 2 by 1. Okay. Now we say that look at the rows of the look at the columns of the first and the rows of the second. If these two are the same, then you can multiply these 2 matrices together. Okay. So what is A times B? What you are going to do, get the matrix, which is 1, 2, 3, 4, 6, 5. Okay. And multiply this by 7 and 8. Okay. Remember, in matrix multiplication, we multiply rows by columns. We get this row and multiply by this column. Okay. So this will be 1 times, let me use the bracket. Okay, 1 times 7. Oh, let me expand on my. Okay, we have 1 times 7 plus 2 times 8. Multiply this by what is here and multiply this by what is here and then add. Okay, then go to the second row and do the same. 3 times 7 plus 4 times 8. Then 6 times 7 plus, this is 5 by 8. So what do we get when we multiply here? What is 1 by 7? Is 7. Okay, 7 plus 16. This is 21 plus 4 by 8 is 32. And 6 by 7 is 42. Okay, plus 40. So what is AB? AB gives us 7 plus 16. You end up with the 23. Okay, and the 21 plus is 53. Okay, and then 82. So the matrix you are getting has how many rows? Let's try to evaluate. There is this row, and this row. It is a 3, okay, by only 1 column. Remember, we said that if this is a 3 by 2, and this is a 2 by 1, then the order will be this of the product matrix will be this and this. Okay, so this is really very simple, and I hope all of you have got this. Part B, or the second part of the question, was to find B times A. And remember, B is 7, 8. Now we want to multiply it by 1, 2, 3, 4, 6, 5. Okay, this is a 2 by 1, and this is a 3 by 2. Okay, so these two, 1 is not equal to 3. Okay, so BA is not possible. Okay, because the number of columns of the first matrix not equal to the number of rows of the second matrix. So we can't multiply matrix B by A. Okay, example, let's see another example. So here we are given 2 matrices, A and B, and they want us to find the AB and BA. There is a reason why this question is asking you to find the AB and the BA. At the end of it, we are going to compare the 2 answers and see if they are the same. If not the same, then we come up with some conclusions. So A times B is equal to, matrix A is 2, 1, 3, and then 1, 0, 4. Okay, and the matrix B is 3, 2, 5, 4, 1, 0, okay, 6, 7, 2. Now this is a 2 by 3, and this is a 3 by 3, okay. These two are the same, okay. 3 equals to 3, so we can multiply, okay. Now that is a compatibility test, and we have tested the two matrices can be multiplied because the number of columns of the first is equal to number of rows of the second, okay. So what do we get when we multiply these matrices? Equals to, okay, this is a bit long, so let's try to be patient. It will be 2 times 3. Multiply this row to this column, first column, okay. Then do the same thing, go to this, then next column, then this, and do row by column at a go. So 2 by 3, 2 goes with a 3 here, okay. 1 goes with a 4, and then a 3 goes with a 6. You get the first entry, okay. 2 times 3 plus 1 times 4 plus 3 times 6, okay. Then let's go to the middle part. This is 2 times 2 plus 1 times 1 plus 3 times 7, okay. Then lastly 2 times 5 plus 1 times 0 plus 3 times 2, okay. Then the downer row, or the second row, we have 1 times 3 plus 0 times 4 plus 4 times 6. Then 1 times 2 plus 0 times 1 plus 4 times 7. Then 1 times 5 plus 0 times 0, then plus 4 times 2. So we close this, okay, close it off, and this gives us 2 times 3. Let's just add directly. 2 times 3 is a 6. 6 plus 4 is 10. 10 plus 18 is 28. Next, 2 plus 2 is a 4, 5. 5 plus 21 is 26. Okay. 2 times 5 is 10. 10 plus 6 is 16. Okay. Then 1 times 3 is 3. Then 4 by 6 is 24. Okay. 24 plus 3 is 27. Okay. 1 times 3. Okay. And 4 by 6. Okay. Then 1 times 2 is 2. And the 4 by 7. 4 by 7 is 28. Okay. So this goes to 30. Then 1 times 5 is a 5. Then 4 by 2 is 8. Okay. 8 and 5, we get 13. So, ladies and gentlemen, we have AB. Okay. Can we try to look at B times A? But, okay. Let me write it, but I think that's compatible. Okay. We have B by A equals to 3, 2, 5, 4, 1, 0, 6, 7, 2. Okay. And we are multiplying this by 2, 1, 3, 1, 0, 4. Okay, what happened is, let's look at number of rows here. There are 3 rows and 3 columns. Okay, that's the size. What about here? These are 2 rows and 3 columns. Now, this is the size of that matrix. Are you seeing that 3 is not equal to 2? Okay, so BA is not possible. Okay, the reason is the number of columns of B is not equal to number of rows of A, and therefore you can't multiply. and therefore cannot make a comment as I had suggested at the start of the solution. Okay. Yeah, I'm giving you this simple exercise, question 1, question 2, question 3. But question 3, let me work out for you the first part, and then we call it a day because this is getting a bit lengthy. It's not good for an online lecture to be very long. So let's work out question 3 and the first part. You have been given something. Okay, this moved a bit, but it is okay. So the first part, they want us to find the value of x, y, and z. We have been given 1, -2, and a 3. Then they have given us 0, 4, -7, and then 0, 0, 2. Okay. Multiply this by x, y, z. Okay. And end up with 1, 2, 4. So what happened is, let's multiply. Go by column. Okay. This row multiplies everything here. You have 1 by x is x. Okay. -2y plus 3z. That's the first element. Then the second element will be, it is going to be 0 times x is 0. Okay. Plus 4y. Let me write it for so well. Plus 4y minus 7z. Then the last one is 0 plus 0. Then plus 2z. Okay. Is equal to 1, 2, and 4. So what do we get? X minus 2y plus 3z. This is where the concept of equal matrices comes into use, because we say that two matrices are equal, okay, if the corresponding elements are the same, and the two matrices have the same order. And this is, a 3 by 1. Both of them are 3 by 1s. So this must be equal to 1. Okay. Then we have 4y minus 7z must be equal to 2. The good news is that 2z is equal to 4. Now, if 2z is equal to 4, okay, z sometimes can be called z. 2z is equal to 4, then z is 4 by 2, which is equal to 2. Okay. Now, if z is equal to 2, and I have 4y minus 7 into z, which is now a 2, okay, must give me a 2. So 4y will be equal to 16 by 4 by 4. And therefore y is equal to 4. Okay. So if y is equal to 4, I know that x minus 2 into a 4 plus 3 into a 2, that must be equal to 1. So x minus 8 plus 6 is equal to 1. And therefore x is equal to 3. Okay, because -8 plus 6, you get -2. Okay, and when a negative crosses the equal signs, then you end up with x is equal to 3. Therefore, we have I've got our x equals to 3, y equals to 4, and z equals to 2. So we are done. Ladies and gentlemen, let's end here today. Then tomorrow we shall look at more questions about matrix multiplication. Then we move on. We have about 201 lesson left, and then we go to another part of matrices, which is going to be transformation.